Better Origin is developing modular insect farms. And today, Miha is going to speak to us about innovation in insect production and the work that Better Origin are doing. I'll hand it over to you, Miha.
Great. Thank you so much for the introduction, Joanna. Hello, everyone. My name is Miha, and I'm the Chief Scientific Officer and founder of Better Origin. And today I was tasked with giving a little bit of an overview of insect production innovations. It's a very, very busy and quickly evolving field, as I'm sure everyone is aware in this room. So my focus will be primarily on the types of innovations that I know are happening definitely within our company. And we shall overview both sort of rearing and processing innovations with a little bit of context. And I very much look forward to answering your questions. So do crack on with posting them. So a little bit about our company to start with. So Better Origin was founded in 2015 in Cambridge. On the picture here, you can see myself and my co-founder, Fotis, in front of our very first Better Origin X1. So this is our first product, and I'll delve in more depth in the coming slides. We are very much still a small company, about 14 employees at this point in time. As with, I suppose, most companies and ventures in this area, regardless of geography, it's a mix of engineers, biologists, and other like-minded individuals who don't mind touching maggots, I suppose. And our focus from the very start has been in how do we sort of deliver insect farming as a real powerful technology for the future of sustainable farming. And our approach to this has led us down a decentralized production route. So what does that mean, and what's the sort of alternative context? You might be familiar that most sort of large-scale enterprises now are focusing on building, single, discrete, large facilities dealing with tens of thousands of tons of waste per year. And that in turn leads to generation of quite a lot of, larvae, and in turn can get turned into meal and all sorts of other products. Now, our approach has been more driven by the nature of how A, larvae are needed, B, how waste occurs, and C, how sort of farming works these days. And that leads to this sort of decentralized, distributed approach. So what that means is that you can start creating sort of a network of local farming nodes, and these are smaller scale facilities that allow you to produce insects on site. So we are still talking tons of insects per year, but we're not talking tens of thousands of tons of waste inputs. This means that, every region, everywhere you drop a pin on Google Maps within a certain 10 or 20 mile radius, you will have plenty of legal waste available, and even more if we are going to deregulate some of those in the future. Now, we hope to basically support the creation of this type of decentralized network. We like to call it the Internet of Insects, and a bit of a joke, but a bit of a truth. And once you have that production, which would emanate to, for example, how crops are grown these days, then we start talking about, a second stage, which is how can you pull these larvae grown at different facilities to different standards and consolidate them into, high quality nutrient streams and extract the most value of these larvae. So these things can happen in a semi-centralized location in what we call sort of processing hubs. And I'll cover this in a bit more depth at the end of this presentation. And ultimately, these networks really benefit from the approaches that Thomas was mentioning earlier. So, really pushing the understanding of genetics and how that can be used to increase yields and resilience, and in turn, sort of drive the performance of the entire network. So today we'll primarily focus on these two. Thomas did a fantastic job of covering the third one, but I'm sure there'll be more opportunities to cover that in the panel discussion. So without further ado, what we see as a rearing innovation in terms of decentralized in particular is our Better Origin X1. So what you're looking at is essentially an ISO shipping container, which has been converted into a black box for magic larvae rearing. So on one end, you put your waste in, and on the other end, you get your black soldier fly larvae out. This is a fully automated process with high autonomy, thanks to the AI farming assistant that takes care of the sort of complicated larvae farming bits and reduces the sort of variability of the crop harvested. And what you're looking at with one of these modules, first generation ones, is roughly 35 tons of larvae per year. And in terms of inputs, this will vary hugely depending on what you put in. But if we're talking about, sort of lower quality organic feedstocks, such as, leafy greens and this kind of vegetable waste, you could be looking at up to 180 tons of waste a year. That number is obviously much, much lower if one were to feed them on, waste grains or dry brewer's grains and things like that, which are higher in their nutrient content. In terms of installing this, it's a fairly simple thing. You need electricity, water, and a way to kind of get rid of the wastewater from the washing and the hygiene that happens inside a container. And crucially, this is, a modular approach. So it means, yes, you can start with one module, but there's also ways to configure these things to really increase yields and reduce costs by pulling multiple of these modules together. In addition, where I would leave this as well, compared to the cost of investments or CapEx for building these facilities, because you don't have a fixed site, because you don't have some of those very expensive utilities that are required to build a large scale facility, the cost in terms of CapEx here is much lower per ton of larvae produced. Now, in terms of usage, there's obviously a lot of ways on how we can use insects. When I say insects here, I'm primarily referring to black soldier fly larvae, which is what we specialize in. And within the context of an X1, the regulatory status in the UK now and most of Europe means that you can only really use the top one. So feed grade materials that could be fed to any other animals. But there's kind of more and more liberation on the food waste front, particularly if this is pre-customer. These types of cleaner inputs in particular can be used to produce the highest quality larvae, which can in turn be used for human nutrition, high-grade animal food, and pet food. But I think what's worth highlighting here is that, if there wasn't this kind of regulatory exclusions in place, there's nothing really stopping those larvae eating, municipal organic waste or even wastewater sludges and what we could deem as dirty waste, such as manures. In those cases, for health and safety purposes, it makes more sense to target them to non-food sectors and non-feed sectors, so production of sustainable chemicals, which are very much needed going forward. But the bottom line is our technology here is quite flexible, so there's really nothing stopping you from exploring those applications if the legislation permits it. But in terms of where we're focusing now, I'll give a little bit of an example of where we've deployed X1s to date, and that's been primarily in the laying hen sector, so the egg production. These hens live for a long period of time, and I could hear in a previous presentation some similar work took place in Isipe. Basically, the concept is quite simple, and oftentimes I laugh about this because it's deemed as innovation, but really we're just going back to the roots. We're feeding, maggots to chickens, which is something that poultry has been doing for millions of years. But the way it works is you get your waste, we provide the seed stock, so this is the baby larvae, the genetics inside the container. They're grown into larvae, and those are fed live directly to laying hens. They're fed live because this is how legislation in the UK and Europe currently works. So live BSF larvae are legal feed tender for all monogastric species, whereas the processed meals currently remain limited, although that is set to change. And in terms of the impacts we've sort of observed with these things, so the most striking one and most important one for farmers is that live insect feeding does seem to support very highly the sort of productivity of hens and the egg quality derived. So there's more eggs, and there's usually more eggs with less feed consumption, which is a double whammy. But very importantly, with something that the poultry sector is facing, we're talking about holistic improvement of health as well. And we've seen this with upregulations in the natural immune status of these birds, as well as much healthier gut. So something that can be seen both at the sort of physiological level as well as in the microbiome level, something of growing importance, particularly in poultry nutrition. What perhaps was a bit more striking is that, particularly I would say in the UK, the welfare of the farmed animals is something that is continually growing in importance, whenever a certain degree of welfare is achieved, there's always one that's kind of going one beyond that. So we've observed that actually with insects, we tend to achieve some of these very highest possible welfare metrics. So these birds actually spend more time foraging, they display more natural behaviors, and conversely, they spend less time pecking at each other and causing injuries and morbidity and mortality. As well as really creating positive experiences that have some potential in almost training flocks. And I think herding chickens is not something that has been mentioned in the past, but it's very much something we've experienced with our products to date. So what you're seeing here is a site where we've deployed our first X1, and these hens have been fed this kind of diet for a few weeks, and very quickly they started associating all the behavior before the insects are spread with the actual insects as a positive result. What you see here is all of them rushing to the truck that is used to deliver these larvae to the shed every day. And this is just an example of what can be done in a segment of monogastric farming. We do anticipate similar benefits will be observed in meat chickens, so broilers, pigs, and there's been some interesting research coming out from that perspective from Wageningen University in the Netherlands, as well as aquaculture, but possibly in the future. Now, if we sort of go forward, I said I'd provide two types of innovation in production. The other one we deal with is called metamorphosis, and it refers to essentially insect fractionation, or the best ways to process insects. And this was raised in the previous Q&A. Ensuring safety is an extremely important part of creating these processed products, particularly for things like the human market, but animal feed is not that much of an exception when it comes to, for example, microbiological health. And from this perspective, a lot of our work over the past 5 years has been in actually how do we develop a process that's suited for insect processing rather than just taking something that was done for dead cows and rendered carcasses from a processing facility. And the result of this is what we call the metamorphosis technology pipeline, which has been now tested with black soldier flies, mealworms, locusts, and crickets. So it's insect agnostic. It effectively, in essence, allows you to separate those insects into relevant nutrient streams in a cost-effective way. So that means protein on one end, fat on one end, and chitin on another one, ultimately leaving the most flexibility towards selling those products to the right market. And this work is being generously supported at this moment by the UK government through Innovate UK, something Thomas highlighted in his previous presentation. So the goal now is to build this pipeline that's been developed over years into a ton an hour processing facility, and that's set to be complete next year. So our hope for these kind of technologies is obviously to be offering them at a global scale. So focus currently is UK, but very much it's not where we want to stop with this. So yeah, I hope this provides a little overview of where we are and what sort of things we're doing. Thanks so much.
Brilliant. Thank you very much, Miha.